Exactly. You've got to do it.
Okay, here we go. Back to the start of this unit. Oh man, it's not looking good. Find the exact value of... Okay, here's the thing. As soon as I see a 12 on the bottom of a fraction, I know this is a question that deals with a 15 or a 75. As soon as I see that 12 on the bottom, does that make sense? Because otherwise our unit circle has 4s, 6s, or 3s. Okay, can you draw that for me? Where are you? Where are you? Think of the fraction 23 over 12. Okay, so we're short of a full circle. And then, what is your distance here then? Basically, are you 15 or are you 75 away? 15. Okay, so I'm now going to do that formula. Because I'm a 15-degree angle, so we're either adding or subtracting these, right? Okay, do you find a formula on your formula sheet? So it's this one. So you're doing a sine cos, subtract a cos sine. Okay, so I'm going to be filling in 4 values. So I'm going to set myself up there. Okay, here's kind of my style. You don't have to do this, but as soon as I see the 45, I put root 2 over 2 because I don't care what it is, cos or sine, they're both the same. Okay. What is the x value at 30? You're looking at a unit circle. What is the y value at 30? You probably are noticing that these formulas with sines and coses are kind of always dealing with the same values. So we get a root 6 minus a root 2 all over 4. All right, just put the fractions together because they were both over 4 over 4. Okay, we need to talk about the Astica quadrant. What do we got here? Astica. What do we know in this quadrant? We're dealing with sine. So sine is going to be negative. Now we're done. Okay, make sure you look at that asterisk at the end though. Okay, tan of 105. So 105 located. Okay, ask yourself, are you 15 or are you 75 off of an x-axis as a reference? 75. So I'm going to go the tan of 45 plus 30. Okay, so now I'm looking at my formula sheet. So I got to find a formula that's a tan of 2 added. So tan 45 plus tan 30 So that's the formula that matches. Okay, the tan at 45 is a little bit easier than the other one. What's the tan at 45? Yeah, at 45 degrees. So here's me looking at my unit circle. The tan is 1, right? Because this y divided by x, 1. Okay, so there's me doing the tan of 45. The tan of 30 degrees. Okay, y divided by x. Do you understand when we do that the long way? Those 2's were always canceling. That will happen. If you need to do it the long way, that's fine. Y divided by x. Okay, so I did it with fractions, but the 2's canceled. Okay, now I'm going to go common denominator. So if this had a root 3 on the bottom, I'm going to turn this into a root 3 over a root 3. So I'm just making the 1 look different. So I'm going to add the bottoms are the same now. So this is root 3 plus 1 over root 3. This is root 3 minus 1 all over root 3. Okay, are we okay to understand at this point, if I times and flip, what's going to occur? If I times and flip, those will end up canceling if you times and you flipped. Okay? But I did times and I flipped those fractions, and that's what would happen. Okay, the last one here. Okay, can you draw me that angle? 17 over 12. 12 over 12. 17 over 12. We good like that? These are my numbers, 6, 12, 18, 24, right? Okay, so if I'm here, I'm a 75 distance away. You either have a 15 or a 75. Okay, so I'm going to do the 45 plus 30. What should I do? I can't do secant. I can't do secant. What should I do instead? Cos. You already can anticipate what I'm going to do at the end. I'm going to flip it at the end, right? Okay. This is my favorite formula. It's cos. When you do this formula, please remember it's the opposite. See how you add fractions? Subtract. Sine is the same, subtract, but cos is the opposite. So formula sheet time, cos minus sine. Okay, I'm just going to give myself some brackets to fill in. Okay, again, my thing is I always like the 45s, and then I just put in the root 2 over 2. And then at 30, make sure you put the x value in and the y value in to the correct spots. Okay, so we have a root 6 minus a root 2, and everything we saw was over 4. Okay, but because we turned the secant to cos, we're now going to have to flip it. So we flipped it back to the secant, and astica. What do we know? Secant will also be the same as the cos, which is positive or negative. Astica negative. Cos is negative. Okay? So you're going to see some of those on your test. Okay. XYR stuff. We're given the sign is positive. So I know I'm in quadrant 1 or 2. Sign is positive. Oh, and it told me I'm in quadrant 2. So I'm in quadrant 2. Okay, do you remember your X, Y, R's? Sine is what over what? A Y and an R, right? A Y and an R. That's last unit. Can you figure out the X part of that triangle? 12 mathematically, and in a location, it's negative, right? Do your math and then do your negatives in your location. Okay, I'm just going to do a little work over here that sine angle is 5 over 13 and cos angle is what would be that fraction? Do you remember cosine? It's the x over the r. Right? Cosine is x over r. Okay. So that's just some work on the background that I have ready to go. Okay, here we go. Cos of double angle. So cos of double angle, you have 3 formulas. Does it matter? Nope. You can pick any 3. Cos of double angle. I'm just going to go with the top one here. So I used my formula sheet and found something. Okay, so I'm going to fill in. So I'm going to take the cos trig value squared. And then I'm going to plug in the sine trig squared. Okay, here's the biggest spot for a mistake to happen. Squaring this. What kind of 144 is it? A positive or a negative? Positive. So make sure positive, negative stuff is good. And you guys might have to help me out here. My mental math Monday skills are not very sharp, as I found out first period here. 119?
Yeah.
That's it. Okay? So do your like pre-work, formula, plug in. Okay, sine of the double angle, you're going to find a formula. This time you only have one option on your formula sheet. So finding the formula, replace with the trig values. So we have them all on the side here ready to go. So 5 over 13 and negative 12 over 13. If you like, you can put that over 1 if that helps you with like your following your multiplying through. Okay, this is where my angle is in quadrant 2. If I doubled that angle, I'm in quadrant 4 because the cos is positive and the sine is negative. So once you doubled that angle, you actually are somewhere in quadrant 4. Does that make sense? Okay, number 3 is working backwards. Can you find a formula that is a cos minus a sine? Cos minus a sine. Cos minus sine. Did you find a formula? So it's matching the cosine of added. The cosine of the add. Okay, cosine of adding. So now I'm going to add that, and it's 8 pi over 24. Okay, can you reduce 8 and 24? That would reduce. Okay, now you have to go to your unit circle. What is the cosine value when you look at pi over 3? So find the pi over 3. What is the cosine there? Is it 1/2? Okay, the x value. Okay, B. Sine cos minus cos sine. We'll find a matching formula. Sine cos. So here's my match. Are we good? Sine of subtracted. Sine of subtracted. That's the formula it matched, which turns into sine of 45. Okay, now it's back to that unit circle. Go to 45. And what's the y coordinate? Okay. That's the working backwards, so you'll definitely have one of those on the test. Okay, a proof.
That's question 6.
What's that?
Skip 2.
I skipped?
Yeah.
What? Mine is all stapled out of whack. Okay, I was just so excited about that proof. Apparently you guys aren't. Okay, this one is where you are, number 4. Okay, let's get this quadrants of A. Let's work with A and B on the side here. A and B. We got to figure out where to draw them, getting our ratios. Okay, what do you know about angle A? The cos is negative. So A could be, in those quadrants, cos negative. And what do we got here? Angle A and B are in the same quadrant. Okay. So A could be there. Where could B, angle B, be located? BB. Where's angle B? Sine is positive. So it could be in the tops. They're in the same quadrant. So what quadrant do they have to be in? 2. Okay, so you have to reason the quadrant stuff out. Okay, cos the cos is -8/17. So where does that all line up in a triangle? -8 and 17. X and R. Cos is X and R. And has anybody done that? Is it a 15? 15? Pythagorean 15, is it a positive or negative? Positive, right? Because it's up. So right now I'm just going to write this info. The sine of A, I like to have all that stuff ready to go. The sine is 15/17. Okay, I don't think I need tan, so I'm not going to worry about it. Angle B, we were given the sine is 24/25. So 24 and 25. Pythagorean, I want to say it's 7, if I know my triples. 7. And it's a negative x. So cos of B is -7/25. Okay. Formula sheet time. We got all, this is just background work. That's all we did was background work. Cos of A subtract B. Cos of A subtract B. Find yourself a formula. Cos, cos plus sine, sine. Cos A, cos B plus. So I found myself a formula. I like to do that. Organize my info. I'm going to replace each thing. Okay, do you have your work all organized on the side? Now you just input what you just did. So find all the stuff you did on the side and plug it in. Okay, 416, 425, that all came out? Okay, how about I let you do the other one all by yourself? Find the formula, we got all the work done, so just plug it in. I'll do it too, but go for it all on your own here. Find the formula, plug the 4 values in. Okay, 87 over 425. Good, that stuff. Okay, number 5. A proof. Ready? We're gonna make a left column and a right column. Decide which side you're gonna start with. So it's the more complicated looking side usually. So I'm going to go on the left. Anybody see a good strategy? I don't think there's anything I can replace with because it's already broken into sines and coses. So there's not really replacements. So I'm not going to go with that. I have 2 fractions. I think I'm going to try to get them together. So I would need a common denominator. Okay, to get a common denominator, I got to maneuver the second fraction. What are you going to have to do to that bottom? You're going to have to times it by a sign. All right, I'm going to have to times it by a sign. which is going to do what to the top when you times the top by a sign? So I times that fraction by a sign on the top and on the bottom. Are you okay? Now I have a common denominator. Okay, so let's just put this together now. Putting that together. Okay, I actually recognize now a formula sheet substitution. And it's in your top section of your formula sheet. Do you see any replacements with formulas in your formula sheet? So check it out. My hint is in that top section. 1 subtract sine squared. You have a 1 and a sine, so you're looking at this something in this. So right here, cosine squared can be replaced. Okay, formula sheet was replaced. Now what? You can cancel a cos. So if it goes out of the top, I'm just going to cross off the square. And if it goes out of the bottom, so I'm left with a cos t over sine t. And what's that fraction the same as? Cotangent, right? A cos over a sine, and you're done. Got it there. Okay? Okay, number 6. Okay, here's my 2 columns. Which side? What's your instinct going with? Which one's more complicated? I think the left. Okay. Do you have any replacements? Usually when you have replacements, you're looking for the squareds. The squareds, all these top formulas are dealing with squareds. Do you see anything? Cotangent squared, could you make a replacement? Did you find here? Cosecant squared minus 1. Okay. Now what? Anybody see anything?
Why is the bottom one, why is that a negative?
That's a really good question because it's Monday, that's why. I was so worried I accidentally wrote secant and then my mind went to what am I doing? Okay. I can do something with this top. There's something I know with last year, the F word on this top. Do you see something? You can factor that out. What is it? It's a difference of squares, right? How do you do that one? So difference of squares. Okay, that helps because now I can cancel, right? And I'm left with cosecant theta minus 1. Okay, I'm going to pause for a second and kind of going to peek more at the right-hand side. I can see it. On this right-hand side, I'm going to split this fraction apart. So can you split that fraction? So 1 over sine theta minus sine theta over sine theta. So I split that one up. I can see the end in sight. The reciprocal sine, so cosecant. And then a sine over a sine is the same as 1. And then we did it. Okay, and then I think I have 2 trig equations here. Okay, trig equation time. What can we replace? So on your formula sheets, you can usually look for the squared stuff because that's our formulas from the top. So cotangent squared. Find something, we're going to go with cosecant squared minus 1. Okay, so I made a replacement. That's all I did. Formula sheet. Okay, I'm going to make it look like a good quadratic. I'm going to put the numbers together. So that was me just combining the -1 and the -2. Okay, we should recognize at that point that we have a simple trinomial and we're going to factor it, or try to factor it. And I got that it does factor. I got something to work. What would you ever do if you played around with your numbers and there was just nothing that worked? What would you do at that point? The quadratic formula. You wouldn't stop and try to make your own factors. Sometimes it doesn't factor, you got the formula. Okay, so cosecant theta equals -3 or 1. Okay, at this point, I need to change it out of cosecant language. So then it's going to change to sines Okay, and then we're going to be reciprocating, so that turns into a -1/3. And what's the reciprocal of 1? Still 1. That doesn't change, right? Do we have any no solutions? Or are they all going to work? They're all going to work. I'm going to do this one first because it's a unit circle number. Where do you ever see a y value of 1 on your unit circle? Where do you see that y value of 1? Right there, the y value is 1. So your answer is in radians because it told me to do that. I knew I had to answer in radians, right? You're always going to look there? Okay, this is not on the unit circle. So we're going to go Astica, calculator, figure it out. Astica, where would you like to be located? Sign negative. Okay, when you're going in your calculator now, no negative, because we're putting the negative in the drawing. What do you want to make sure you're in? Radian mode. RAD or R, whatever your calculator does. Radian. Second sign of 1/3. I'm going to write this to 4 decimals right now because I don't want to round. I don't want to round too early. I think on the first test, maybe that caused a few people to get a rounding mistake because this is not my final answer, so I'm not rounding it. Okay, so I'm going to go pi plus. Pi plus answer. Pi plus the answer is 3.481. You know what I always do? I just minus the pi so that I can just get back to I get back there. So now I'm never having to round anything. 2 pi minus the answer. So 2 pi minus the answer is 5.943. So I did that calculator work with ever having to actually round anything till the very end, right? Okay, I guess we have one more here. Okay. We're going to make a replacement. This formula or this equation right now has sines and coses in it. I don't like it. So we can make a replacement for sine squared because that's our formula sheet stuff. So formula sheet sine squared. Make a replacement from what you're seeing. Okay. Replacement. Now distribute some stuff. Be careful, make sure that 2 goes through everything. That would be a little bit of a mistake I often see, just forgetting that 2. On the second part of that distribute, okay, so at this point, I hope you can recognize quadratic equation, right? So I'm going to go on one side and zero out the other. I don't like factoring with negatives, so I want to end up with that over there. So I'm just going to be moving everything right. I'm moving everything right. So now it's 2 cos squared minus 3 cos. And what do you get as a number there? We're moving the number. So make sure you get the number correct. When you move 3, subtract 2. Okay, let's try to factor this out. So 2 cos theta and a cos theta. Well, your last is nice because it's 1. So they're both 1. Does it work out? Are you going to be able to get a negative 3? And a positive 1, yep. Outsides and insides will make negative 3. Okay, so getting your trig values, we have cos theta is 1/2 and cos theta is 1. I'm not touching my calculator. I see everything would be on a unit circle here. So where do I see x values of a half? X values of a half. And I should answer in degrees on this one, because it says from 0 to 360 degrees. So now this would be, what, 60? I'm not looking at a unit circle, am I good? 60? And 60 degrees this way would be 300. And now I'm going to look for unit circle wherever I see x of 1. X of 1 over there. Ooh, I better double check my domain. Okay, I can include 0 and 360. So then I'm going to do that. I better answer both because I have to include both. What if your question ever said for all angles? What would you do? If your question ever says for all angles or real values, you have to add. Do you remember that? So make sure you add that if your question says that. This one didn't, the other one didn't. Okay, so just remember that little sentence.